Hello, my name is Kerry Isco, Avnet's Global Director of LEDs and Smart Lighting. I'm here at LIGHTFAIR 2015 in Manhattan at the Avnet Lightspeed booth. I'd like to show you some of the developments in chip-on-board LEDs, and most specifically, the ecosystem around them. This is an example of a chip-on-board LED. This particular one is made by Citizen. It's one of the largest available. And in addition to the tremendous volume of light, it does produce a fair amount of heat. How do you produce a light engine using a chip-on-board LED that offers the lifetime and the least amount of color shift? It has to do with temperature. It has to do with thermal management. We've built a system that demonstrates the advantages of that proper thermal management system. In the first case, we have a Citizen CoB. In this case, it's a CLL 042 mounted to a thick piece of aluminum. We're driving that with a Fairchild FL7733A power solution and monitoring the temperature. The temperature of a certain position on that metal is 53 degrees C. That's a little hot. The lifetime of that chip-on-board LED, irrespective of what chip-on-board LED it is going to be compromised, and the light and the color characteristics may shift a little bit. In the next case, we've added a passive cooler. In this case, it's a large heatsink, multi-fins. Air is convectively pulling some of the heat out and bringing it out to ambient. If we look at the temperature, it's 46 degrees C. So we've gone from 52 to 46. A net decrease of 8 degrees, that's a benefit. That LED will operate better. But in the last case, we've added something interesting, an EBM Pabst active cooler. That active cooler is a specially designed fan, 307,000 hours of operation, specifically intended for lighting applications because of the low noise and low vibration and the efficacy. I look at the temperature in that same position, it's 26 degrees C. So by adding a little bit more of the active cooling management, we've gone from 53 to 46 to 26 degrees C. Another way to visually look at this, we have a magnifying glass that's been retrofitted using a FLIR thermal imager. This is a system that basically sees heat signatures. It's really military technology originally, now as small as that device. By holding this thermal imager up to each of these solutions, we can notice that in the center design, there is a bright yellow-orange hot spot, and that's the heat that is being pulled out on that passive heatsink, but stopping there. It is not getting out into the ambient air effectively. If I then look at that same position on the EBM Pabst active cooler, I do not see any flare. I do not see any hot spots. That's because it's operating very effectively. So it's another way to visually test, to validate where the hot spots are and that that's being managed. Our ultimate goal is to provide an ecosystem so that chip-on-board LED becomes a light engine that offers the highest amount of light for the greatest amount of time at the highest quality level. Thank you so much.